So our learning target today is we're going to use measures of center, like the one we just talked about for our test grade, and measures of variation to describe data sets. So the very first thing in your notes that it asks you to fill out is, what are statistics? Well, they are the numbers used to summarize and compare data. Numbers used to summarize and compare data. Make sure, close out of that. So who here wants to be a statistician when they grow up? Just can't wait to become a statistician. Exactly, right? No, there are very few. That's right, Mr. Olson.
I love
That's
it.
right.
I use stats every day during the spring. Mayfield, you know what I'm talking about.
Yep.
Okay. Your catching percentage, you're hitting I want to be one. Okay.
I love it, Mr. Olson. I love it. So that's the thing, right? Most people that work with statistics do not go into a particular field to be a statistician. I am a teacher, right? Obviously I'm a math teacher, but every teacher in this building has to run statistics on their class performance, right? Why do we get all that math data, right? What are we looking at? We have to compare, how is this class doing versus last year? How are they doing in the fall versus the winter time? So even though you may not think that you're going to be a statistician, there are so many fields that use statistics, you will probably come across them at some point in whatever you decide to go into. So we're going to watch just a little 3-minute video.
I use statistics in my job as a journalist every day and for pretty much everything I do. It's essential. It affects how I think about every story I write, every story I edit, every story I read and consider in terms of it being a possibility for something to follow up on.
Whenever people talk about, they say, well, one day you're going to use this. You're taking these math classes. They're like, really, you're going to use this? You will use it if you study statistics. Because when it comes to statistics, you have this toolbox that allows you to understand all of these different parts, not just of the economy, but of our society, of different parts of like your life. So the sooner that you study statistics, really, not only will you be better in whatever career you choose, but it's really going to go a very long way in helping you just in your daily parts of life.
I think often people think that with mathematics or statistics, you're going to be behind a computer all day doing nothing. But data can benefit every community and every population. You can become an expert in data collection and data analysis, consulting on data matters, or presenting the results of your data analysis, and that can take you around the world. Because right now, everybody needs quantitative evidence and statistics to support their decision making. So absolutely, studying statistics is very important.
For my job, statistics is essential. It really is the tool that allowed us to use data properly and to make insightful conclusions out of it. Without statistics, our data would just be meaningless, really, because we wouldn't be able to use it properly.
I would find it harder to name a field in which statistics isn't important than one in which it is. It's clearly important now in journalism. It's also obviously important in science and math and statistics, but I've written during my career about just about every other field, and statistics comes up in all of them. Any kind of humanities disciplines, sports, it's incredibly important now in sports in a way that it wasn't before. It's important, obviously, in business, but really at all levels of business, even just your own personal business. You need to understand data and be able to analyze it and understand what it's really telling you and ignore the noise.
All right, so that's my plug for statistics, because you really will use it. I know you may think right now that you won't, but it is going to come up in whatever field you wind up going into. So here's my recommendation. Don't be afraid of the data. Don't be afraid to be that person in the office that you work in. Like you want to be that person that people go to, right? Countless people in this building will come to me and say, hey, can you just run some numbers on this? Right? Is after school study hall, is win time really helping our students? And I can clearly see that yes, like I can look at grades before and after and clearly see that yes, this is having a direct impact on student grades. So that's my big plug, okay? In the future, students will probably be taking more statistical classes in high school than they are today because there's so much data in the world and we need help analyzing it. And who's gonna be there to analyze it? Your generation. So I know it probably may seem like I'm just on my stool here talking about this, but it is really important stuff. But unfortunately, I only get to cover it with you for a day. If you're interested in taking more statistics, right, that's why we have an entire semester-long course dedicated to statistics. Mr. Titus teaches it. So we're going to start with kind of the basic, right? We're going to start with what we call measures of central tendency. These are used to represent the center of our data, okay? So that's why we call them central tendency numbers. I typed these in just to make sure everybody could read the handwriting okay. We have three main ones that we talk about. So here's where you're starting to write down things in your notes. The first is the mean, okay? Mean is usually when people say the average, we assume that they're talking about mean, but sometimes they're not, right? These are all measures of central tendency. We could refer to all of them as average. So what you see is X with this little bar over it. That's kind of the fancy way that we would identify that this is the mean. All you do, right, is you add up each one of your data points and you divide by the number of data points in your data set. I think we all here probably calculated the mean at some point in our lives, so not too bad. The next one is our median, and that's in the middle. So we've got to order everything. We've got to put everything in order, usually in increasing order, because that's just kind of how our minds operate. And then we find the middle. Oh, it's not plugged in, I'm sorry. My students unplugged it last class to plug in their laptops. If there are two numbers in the middle, you then must take the average of those two. You must take the mean of those two numbers. So if we have an even data set, we may have to do that. The last one is called the mode. And we use the mode, or we refer to the mode as the mode is the most. What number appears most often? Now last year, the AP statistics exam officially took mode off of their list of data points. So I do think mode will eventually kind of be kicked out. It's not necessarily one that we always want to consider. But students always ask, what if there's no number that is repeated 2 or 3 times? Well, then you can say my data set has no mode. Or what if there are multiple points that occur the same frequency? We would say that both of these represent the mode. You don't average them or anything, you just list out these are all the modes. Kind of a weird way, but that's how they do it. Any questions on those 3 definitions, vocabulary terms? You'll definitely be required to know those. So right below is your first question. Let's go ahead and calculate the mean, the median, and the mode. So what we did is imagine we went to a doctor's office and we collected waiting times, right? Nobody likes to wait out in the waiting room at the doctor's office. So you may be more inclined to go to a doctor's office that has a very short waiting time so that it doesn't kind of mess up your day. Let's go ahead and, yes, we're going to use our calculators. I'm not expecting you to calculate all this by hand, so type that in. How many numbers do we have in our data set? 9. So we're going to add all those up and divide by 9. What do we get? 22. Perfect. So you notice I kind of used that new symbology that we just discovered, right? X with the bar over it. So that's our mean value. Now the median, I was kind of nice, right? I put everything in order for you. So our median, I can just kind of cross out, or I can count my way in and see that my median is 20. It's the number right in the middle. And then the other one is the mode. What number appears the most frequently?
24.
24. So usually when we talk about data sets, we want these two things to be about the same thing. Now we don't have a ton of data points because I don't want us to be here all day. But yes, right, they're pretty close, pretty close. Now let's do the same thing for a doctor's office beat. Now you'll notice here, we can start to use our calculators if we'd like to. You do have a stat button on your calculator. And then you can hit edit. Let me see if my calculator is still pulled up here. Oh, it's going to ask me to sign in. All right, so I can hit the stat button and then hit edit. And I can enter in all these different data points. Now you just have to decide, right, which one is going to be the fastest way to do this. Is it just adding them up yourself and doing it by hand? Or is it using this here? Right, so once we get all those numbers in there, I can go to stat, calc, one variable stats. So that was stat, calc, one variable stats, and hit enter. And so right away, we're going to see right on top what our mean is. So our mean is 16. If I scroll down a little bit, I'm also going to see all this extra information. Q1, Q3, this is kind of nice that your calculator is doing all this for you. You'll see how we're going to use it later. My median is 18. So we are definitely going to use our calculator a bit more as we get into kind of the more advanced things. So our mean, that was 16. Our median was 18. And what's our mode? 18. All right, so which doctor's office do you want to go to? B, right? The only reason why we do this is so that we can actually make decisions based off of it. Questions on mean, median, and mode? Okay. The next thing is what's called a box and whisker plot. You guys ever seen a box and whisker plot before? Okay, so I know Mr. Titus likes to use these a lot. Oftentimes, right, when we analyze test scores, especially final grades, we want to see, okay, is the data really spread out, or is it this nice little box where most of the people scored kind of in this range? So the interquartile range is Q3 minus Q1. We're going to need all of these data points to be able to draw a box and whisker plot. Q1 is the median of the first half of your data. So you're going to take the first half of your data. You're going to forget that other half of your data exists. And you're just going to look at that first half and say, okay, what's the middle of the first half? Q3 is going to be the median of the second half of your data. Make sure you have all these down in your notes. Definitions here. And then I put a little picture in there so you can kind of see where all of these data points go when you're drawing a box and whisker plot. Sometimes, though, we just want to see the range, right? What was the highest score that somebody got, and what was the lowest score that somebody got? So this, I know that it's not listed in your notes right now as a definition, but I would write this one down, because it's going to come up. I have it repeated a couple times, but add range into your notes where we just calculate the max versus the min. It's not the interquartile range, which is just kind of those middle points. It is the full range of data points that we were able to see. So we're gonna use this information, and yeah, I know sometimes statistics can be a little time consuming. We are going to create a box and whisker plot for this lovely data set we have on the next page. I know, it's just to get us some practice, right, so we know how to do these things. Now when I look at this data set, is it in order? No, so I gotta put everything in order, okay? So let's go ahead and do that. I'm gonna kind of cross out as I go. And it's really easy to make a mistake. I could also, put some of this into my calculator to double check, but I'm just gonna have us do some of this by hand. We got 2 5s, got a 6. Okay, so we've got everything in order. Whew. We're going to eventually draw a box and whisker plot. Okay, so basically it means the box is going to be in the center with your interquartile range, and then the whiskers are going to be out to your minimum and maximum. So what's your minimum value? 2, right? That's your min. And your max, 15. So as I draw this box and whisker plot, I've got to make sure it goes all the way from 2 to 15. So I'm going to put a dot right here at 2 and a dot up here at 15. Right? Those represent my max and my minimum value. What is the median of this data set? Oh. So I have an even number of data points in this data set. So when you do that, right, that means you don't have just one number in the middle. At this point, we have 2 numbers in the middle. So I have to take the average, or the mean, of these 2 things, 7.5. So that is going to be the middle point of my box here. So I'm going to draw, instead of drawing a point, I'm going to draw a line segment at 7.5. Now let's find Q1. I'm only going to look at this half of the data here. And I'm going to find the middle of that data set there. Everybody get 4? So that is where kind of my box ends down here, is at Q4. Let's find Q3, the middle of the top half of my data set. I get 9. So that is where kind of the box is going to end there. I draw my box, and I draw the whiskers. Questions on how we drew that, kind of from scratch? Okay, what is my interquartile range calculation? Called IQR. Q3 minus Q1. 9 minus 4, 5. Right? So that was one of our questions. Want to find the interquartile range. Now, looking at this, are my whiskers the same size?
No.
No. Is the box the same size on the left and the right?
No.
No. We call this data skewed. And I know we like data to be nice and symmetric and normal, but to be honest, in the real world, data is often skewed one way or the other. All right, let's analyze. If I've given you a box and whisker plot here, I want to find the median, the range, and the interquartile range of this data. So what is my median value? 22, right? Right there in the middle. Down here at 18, we have Q1. Up here we have Q3 up at 26. So what is my interquartile range? 8. Yep, 26 minus 18, 8. And then my full range, 16 represents my minimum, 28 represents my maximum. So what is the range?
12.
Yep. Now looking at this data, are my whiskers the same size?
Yes.
Is my box the same size on left and right?
Yep.
This is what we would call symmetric data. It's nice and even and looks great, right? It's a normal data set probably. Now given we don't have all the information, can you tell me all the data points that went into making this box and whisker plot?
No.
You cannot back out those data points. That is the tricky part about these types of things. You don't know all of the data, you only know this summary of the data. And sometimes that's enough. All right, the next thing we're going to do, I know, lots of things here, is we're going to create what's called a line plot. Sometimes it's called a dot plot. It's just a different way to look at different data sets, okay? Right now, here we have some data about, it gives a random sample of 20 babies born at a hospital. It gives their birth month, so the month that they were born, their birth weight, and then the mother's age, right? There's always that fear that as we get older, ladies, right, and if we have babies, that maybe sometimes there might be complications with that. Obviously, modern medicine keeps getting better every year, but that is the case. First, we're going to create a line plot for birth month. Maybe there's like a month where a lot of babies were born, right? 9 months after Christmas or something like that, who knows? So let's fill it in with a line plot. I'm going to use X's, you can use dots, you can use whatever is most comfortable. So I got 5, and then 7, 11, so once you get 2 in the same month, you're just going to stack those X's on top of each other. All right, so we filled out this data. Does it seem like there's one month that you're more likely to give birth? No, right? This is only a sample of 20 women, so it's really not that big, but it's not like there's one month that stands out to us. So sometimes you just want to graphically represent this data to get an idea of what it looks like. Now we're going to do the same thing down here for birth weight and mother's age. And I know, time consuming, so take your time. Let's fill it out. Alright, once you get done with that, I want this half of the room over here to figure out the birth weight, mean, median, and mode. And I want this half of the class to figure out the mother's age, mean, median, and mode. That way we can share it and we don't all have to do the same workload. You guys are doing birth weight, calculate mean, median, mode. It's kind of easier to plug this information into the calculator when you've got it in this nice order, right? You know how many of these. You can even use multiplication, right? 3.2 plus 2 times 3.3 plus 4 times 3.4 if you wanted to. Okay? Guys to check your work with each other here because I don't have them written down this way. Might need to write them down so I have to put them. How do you get the mode if they're... You can list both numbers. Yep. Good question.
Scroll down a little bit.
Did you guys have the same mean?
Yeah.
Okay.
When you go, I use stat, and then you go to calc, and then type in that stat, then you scroll down multiplication. It's the same as
Is what happens, right? It's really easy to make a mistake when you have all these data sets. This is why you always want your data in some kind of spreadsheet
and then
rather than written down. All right, let's go over these together. You can help, even if you don't have them all done. Hopefully, a few people in your group have them done. All right, let's talk birth weight first. What do we got for mean? 3.5. What do we got for median? 3.5. What do we got for mode? 3.5. Okay, so the reason why, I kind of knew this one even without having it written down. What we have here, it's what's called a perfectly symmetric normal curve. Normal, symmetric. When you have a perfectly normal curve, which probably never exists in the real world, but sometimes it'll come up, that means all of these things should be the same. Whatever measure of central tendency you decide to use should give you the same result. Now over here, it's not the case. What'd you guys get for your mean?
31.15.
31.15. Median?
30.5.
30.5. Mode?
29 and 30.
29 and 30, right? We've got two things that are repeated the same amount of time, so I just have to list both of them. I don't average them. I don't do anything like that. Now, when I look at this curve here, it doesn't have a nice normal shape, right? This is called skewed. And of course, because, mathematicians, Do you think it's skewed left or right?
Left.
You know what? It's all about where the tail is. Right.
I'm trying to think backwards.
I agree as well. So it's almost like think about which way it's skewed to and then just think the opposite of it because that's what it is. This tells me that the data is not necessarily normal, right? We've got some, not necessarily outliers, but we've got some things in there that are changing the data set a bit. So let's answer some questions about this. What do you notice about the mean and median, we already just talked about, as compared with the mean and median for the skewed distribution? So when they're normal, so when it's skewed, mean usually won't equal median. Whereas when it's normal, you're going to get that mean and median are the same thing. So we're going to answer 4 questions, and the answer is either going to be mother's age or birth weight, based on kind of the classifications here. So number 1, the median is more than the mode.
Mother's age.
Mother's age. I know you've got to look at the data in front of you. I don't have it up on the board right now. The median is less than the mean.
Mother's age.
Mother's age. The mode is equal to the mean.
Birth weight.
Birth weight. And the mean is equal to the median.
Birth weight.
Birth weight. So as long as we can kind of analyze the data afterwards, right, give some summaries of information, that's really what the expectation is going to be on these. Question on measures of central tendency. Usually the easy ones, right, we can knock out of the park a little bit. Now let's get into our next discussion, which is about dispersion, variation, variability, all these things that tell us, right? We love it when data is clustered around our mean, right? Everything is like really close to what we want it to be. But in the real world, data sets are not always clustered around the mean. Sometimes they're spread out. And so the spread of the data becomes really, really important. Has everybody heard that they've taken the Johnson & Johnson shot off the market for right now, the vaccine? No, you guys haven't heard? So there have been 6 women in the United States that have had side effects from the Johnson & Johnson vaccine. Now granted, they've given 6 million shots out, so 6 out of 6 million is really not that bad. But the CDC says, we're concerned, so we're going to put a pause on the Johnson & Johnson vaccine for a little bit. And they want to know, right, okay, so we know that it's happening in women. Well, what's the age range? Right now, the age range is 18 to 48 years old. They want to know, right, how spread out is that data? Because they were really hoping that maybe it was only occurring in elderly women or it was only occurring in really young women. But that spread of 18 to 48, that's a huge part of the population that may not be able to get the vaccine, the Johnson & Johnson version of it. So the spread of the data is really important. I know that we always talk about mean, median, and mode, but spread is something that we want to consider. Now, unfortunately, with spread comes more advanced calculations. Because you're going to say, what is all this stuff? What is this, right? So the range we know, right? Max versus min, that kind of will tell you, right, the spread of your data, the highest versus the lowest. But right here are 2 new things. This is called sigma squared or variance. This little symbol here, sigma. This little thing here, summation. And don't worry, this is where we're going to use our calculators to help us do this, okay? What this does is it takes every single data point and it sees how far away it is from the mean. How far is each and every single data point away from the mean? Then we square that, and we divide that by the number of data points in the data set. Yes, I'm going to make us do one by hand. Just one, so we get a feel for it, and then I promise I'll let you use your calculator. Now, most of the time, people don't want to talk about variance or they never really heard of it. They usually talk about this data point here called standard deviation. Has anybody in here ever heard of the term standard deviation? No. Okay. Standard deviation is the one that is most commonly discussed when we talk about the spread of data. We take our variance and we take the square root of it. So we basically take this calculation and we make it even more complex. Sorry, flip charts puts in that little box down there. You still have the exact same calculation, you just wind up taking the square root of it. So don't get overwhelmed by this formula, right? We're in Algebra 2, so unfortunately what we're doing is some of the more advanced stuff, right? Some of these big symbols that we haven't seen before. Like I said, we're going to do one example together to make sure we know how we're really calculating the spread, and then I won't make you do it. I'll let you use your calculator going forward. Everybody got those down? Okay, let's look at our data set. Oh, first, I wanted to show you this picture, because sometimes students will say, what do you mean by spread? This is going to have a much larger standard deviation than this, right? This data is really spread out. This data is all clustered around the mean. And that's why it's another important data point for us to know so that we can analyze data sets. This is also a really, this is like one of the most basic things that if you do take a statistics class, you will learn about. This is called the normal curve. And so right now, my students are preparing for their AP test that they're going to be taking, and they say, I had them take a practice test, and they said, okay, if I got 10 wrong on the practice test, what will that give me? Will that give me a 1, 2, 3, 4, or 5? And I say, I can try to estimate, but what the AP, what the College Board does is they get all the tests back, and they say, we want a perfect normal curve. So maybe last year, an 85% would have earned you a 4 on it, and maybe this year, an 85% would have given you a 5. Because they always like readapt their test results to this normal curve. This is your mean right here in the middle, and then these are one standard deviation below, one standard deviation above. Two standard deviations above, two standard deviations below. Okay? So if you see a curve like this, right, know it is one of the most foundational things that we use in statistics. Let's go back to our doctor's office, okay? Data we've seen before. We are going to calculate the standard deviation and the range. Why don't we get the range out of the way first? So how do I calculate the range again?
Maximum minus min.
Just max minus min. 18. Now what we're going to do is we're going to start by calculating variance, which is sigma squared. In order to do that, I need to know the mean of this data set. So we have it written down from our previous time we did this. What was the mean for this data set? Doctor's office A? 22, thank you. So the mean of this data set we figured out was 22. We are now going to take the difference between each of these data points and square it and add them together one at a time. I know, Justin, don't get mad about it. It happens, we can do it. So 22 minus 14, 22 minus 14, 8. 8 squared, 64. 22 minus 17, 5 squared, 25. 22 minus 18, 4 squared, 16. 22 minus 19, 3 squared. 22 minus 20, 2 squared. Everybody kind of seeing the pattern that how I'm calculating these? That's in my numerator. And my denominator is how many data points? Thank you. So we're going to add all that up. My numerator, get my numerator, and then divide by 9. And that will be my variance, or my sigma squared. we can round to the first decimal. At least we are gonna need at least one decimal. 290 on the top, so 290 divided by 9. 32.2, 32.2, repeating, right? So in order to calculate the standard deviation, this is the thing that I usually want. I have to take the square root of this number. So I take square root of 32.2, help me out. 5.67. So the standard deviation of this data set, the spread of this data set is 5.67. Now the first question you might ask yourself is that a high standard deviation? It depends is the answer, and I know that you probably hate answers like that, but we need something to compare it to. So let's compare this standard deviation to this one. No, we're not going to do it by hand this time. We're going to do it using our calculators. You may already have this data set saved in there from the first time we did it. Go back over to my calculator here. See? So what I'm looking for is that little sigma, and it's going to have an x next to it. So I see it's right here. Does everybody still have those stats in front of them, or do you need to? Okay. So you go to Stat, Edit, and you put in all of your data points. So we're going to do this for Doctor's Office B. So just put them down all in L1. And then when you're done putting them in L1, you go to Stat, Calc, and it's the very first thing that we want to calculate. We want to calculate one variable statistics. You hit enter again until data actually appears on the screen in front of you. Right? And it's going to start with your mean, and then at the very bottom here, before you even scroll down, you're going to see sigma x. So the standard deviation of this data set is, let's go with 4.5. Does everybody see that on their calculator? Anybody see anything different?
Yeah. Mine is different. Yeah, but mine, when I did not here, I need the, hold on. I need
Need the what? Usually it comes down to we just missed something, right? We forgot to enter a data point into the system, something like that. Got it? Okay. The other data point that we were looking for was the range, right? Max minus min. So now that we have both of these data points from both data sets, which data set is more spread out?
B.
Which has a higher standard deviation? So this data is more spread out because the sigma for A is greater than the sigma for B. Right now that we have something to compare this to, we say since my standard deviation is higher in A, not only did they have an average longer wait time, but the data is so spread out, it's kind of a crapshoot, right? Am I going to go there and I'm going to have to wait 37 minutes, right? The data could be so spread out that I might end up waiting longer than I really wanted to. So when you get your homework assignment, I do think one of the questions asks you to calculate standard deviation by hand, and then the rest of them you can just use your calculator. I would recommend trying it by hand first and then verifying on the calculator, although I will never know, right? As long as we know how to use our calculators, that's good. Kind of the final piece of introductory vocabulary when it comes to statistics is the word outlier. And everybody has their own kind of definition about outlier. If you're in middle school, you usually just say, well, does it look like it's far apart from the center? Then we usually call it an outlier. Whereas as you get more advanced, we need to have some kind of mathematical calculation for figuring out the outlier. So here is Miss Sedlick's calculation for figuring out if there is an outlier. Hopefully you can read that. It looks smaller than I had anticipated. It is. I do. You got it. You're gonna do great, Juliana. You've got this. Let me give you the homework. Okay. Hopefully you can do that. Thank you. So there's the first two worksheets. There's 2 9 ones, so you'll have to do both of them. One for mean, median, and mode, and one for standard deviation. So we have 2 examples in here where I want you to figure out the mean, the median, the mode, the range, and the standard deviation. The fastest way to do this is using your calculator, right? So once you have this outlier down, this definition down, pick up your calculator and go to Stat Edit and overwrite or clear out what's in that list and enter this information here. Notice it's not in order, and the thing is your calculator doesn't care. Your calculator can figure out the median without it being in order, so you do not have to order everything. You find the difference between each point and the mean, and you square it. No. What's the mean? 22. 22 minus 14.
Oh, minus 12.
And then you square it. 64. Right? 22 minus 14 is 8. 8 squared is 64.
So 22 minus 6 is around 50.
Yes, exactly. And you find the difference and you square it. Yep. Nope, I'm glad you asked me. Everybody got that definition down? I can jump over to my calculator.
Wait, we have to have it in order.
Nope, your calculator can do it. Sorry, what was your question?
What do you do on the calculator after you put in the numbers?
Okay, yep, Levy. So once you've got your numbers in there, you go back to your stat button, but instead of going into the edit, you're gonna go over to the right. Choose calculate, choose the calc menu. And you want that first one that's called one variable statistics. We're not gonna get into all this fancy stuff, okay? Hit enter, and then enter again. So hopefully we all got the same stuff. I'll write this, well, I'm recording it, so you should probably write it. Everybody got the same information in front of them? So I can transfer back to our note sheet here. Okay, so you're gonna have to be my information here. Smart word, not so smart. I know, now my Internet Explorer is gonna open up. All right, what is my mean value? I got 11.4 as well, perfect. What is the median value? You should see it on the calculator. You may have to scroll down. What'd you get? 9, that's right. It will say MED. What is the mode? Now this one is not on your calculator. You're just gonna have to look at the data set and figure out what number repeats the most.
8.
8. What is my range? 18, right? I do max versus min. And then last but not least, our standard deviation.
5.78.
5 point, yeah, we can just go with 8. That's perfectly fine rounding, right? 7, 8 would be fine too. So now that I know my standard deviation, the question is there an outlier with this data set? So here's how you figure out, is there an outlier or not? You're going to take the mean, and you're going to add or subtract. You're going to have to do both. 3 times the standard deviation. That's Ms. Sedlick's rule. It's really hard to be an outlier. Really, really hard. So I'm going to do 5.8 times 3, and I'm going to add that to my standard deviation, or to my mean of 11.4. So I get 28.8 as kind of my high one, and then the other one minus 3 times -6.
No.
Oh. No outliers. In the real world, it's really hard to find outliers as well, right? There's always a case to be made for why a data point is not necessarily an outlier. Questions on how we try to figure out if there was an outlier, because I know that's usually what comes up. We have a similar question next. We're going to skip it. Does everybody feel confident they can calculate all of these things using the calculator? I don't necessarily think we have to go through a whole nother example. So, right, usually at your level, it's not necessarily how to calculate these things, it's the application. What does it mean? Say I have an outlier. How is it going to affect my standard deviation? Is my data, so say my data was like really chunked around the mean, and then I added an outlier over here. Is my standard deviation going to be the same?
No.
No. Is my data more spread out now that I've got this data? Yes. So standard deviation is going to go up, right? It's going to get bigger. How about the mean? Say my outlier is a small number, a little teeny tiny number thrown in there. What's it going to do to my mean?
Drop it.
Drop it. Mean decreases. If my outlier is big, mean increases. So I know in mathematics we always have these rules, right? And I've been telling you rules all year long, right? With exponents, this is what we do. We keep the base, subtract our exponents, right? There's all these rules. Unfortunately, when it comes to statistics, there's never one rule of thumb. You talk to one statistician and they do it one way. You talk to another statistician and they do it a different way. It's quite annoying, right? This is why sometimes the data that you read in news articles, you have to question sometimes, right? Even when Mr. Olson runs his stats for the baseball team, if he uses median versus mean, it could tell a completely different story. So, if you have a data set that contains an outlier, that's 4 standard deviations away from the mean. So we know it's a big run, right? We know it's definitely an outlier. Would you use mean or median as your measure of central tendency? Matthew?
I'm gonna guess and say mean.
You say mean, okay? Why would you use the mean?
I feel like if you use median, it won't be quite as accurate because you just get that one that's really far out there compared to the one that's value.
So you don't want to exclude that outlier, right? You want to make it count towards your average, or else maybe you wouldn't be telling the whole story. I see that. Anybody want to play devil's advocate and say median?
We can understand both sides.
Yeah, median.
Are you saying it for real, Carter, or
No.
no? You're just what gets us to homework faster?
Yeah.
Listen, it's out for debate, okay? There are instances where you may want to use the median because you think it tells a better story about your data. There are instances where you feel like mean is really going to be more representative of the data that you received. This is why even just asking a simple question of should I use the mean or the median is not one that anyone can always agree on. So just think about that the next time. And really, there's no answer to this question. The answer is whatever you think is right, right? When you are the owner of the data, you get to decide what is the right approach there. So I'll hand out your homework. You do have 2 worksheets.